Problem number 5 reads, a cue ball moving at 2.2 meters per second strikes a stationary 8 ball. After the collision, the 8 ball moves at a speed of 1.1 meters per second in a direction that makes an angle of 60 degrees with the original direction of the cue ball. What is the speed and direction of the cue ball after the collision? Let's first take a look at that collision. Our cue ball comes in from the left, strikes the 8 ball, and both of them then go off after the collision. Let's set up a coordinate system with its origin at the point of impact, and then draw a vector representing the original momentum of the cue ball, a vector representing the final momentum of the cue ball, and a vector representing the final momentum of the 8 ball. This angle, we are told, is 60 degrees. The angle made by the cue ball and the original direction we don't know. Let's call it theta. That's one of the things we want to find in the problem. We also want to find the speed of the cue ball along this direction. Call this our x-axis and this our y-axis. And a hint before you solve this problem. The vector nature of momentum allows us to state the conservation of momentum law in the following way. The initial momentum of the system in the x direction is equal to the final momentum of the system in the x direction. And the initial momentum of the system in the y direction is equal to the final momentum of the system in the y direction. Try to solve that problem now before watching its solution. Here's a diagram representing the momenta. The mass of the cue ball and the 8 ball is not given. The mass is the same, and we'll just call it m. The momentum of the cue ball before the collision is the mass times its velocity, 2.2 meters per second. After the collision, the momentum of the cue ball is just m times some unknown velocity v, which we're trying to find, and it goes off making some angle theta with respect to the x-axis. The momentum of the 8 ball is its mass times 1.1 meter per second. We're told that it makes an angle of 60 degrees with the original direction of the cue ball, which we have placed along the x-axis. Applying to the conservation of momentum to this system in the x direction, we would have that the original momentum of the system in the x direction is m times 2.2 meters per second. The final momentum in the x direction is found by finding the components of that momentum for each of the balls. For the cue ball, the component is mv cosine theta in the x direction, so we write that. For the 8 ball, it too has a component in the x direction, which is its mass times 1.1 meters per second times the cosine of 60 degrees. The mass appears in each term in this equation and can be canceled out. And we can rewrite this as 2.2 meters per second is equal to v cosine theta plus 1.1 meters per second times the cosine of 60 degrees, which turns out to be 0.55 meters per second. If we solve this for v cosine theta, we could write that v cosine theta then is equal to 2.2 meters per second minus 0.55 meters per second, which turns out to be 1.65 meters per second. We can't go any further with this equation. We do not know either v or theta. So we look at the momentum now in the y direction. In the y direction, the original momentum, since the cue ball is along our x-axis, the original momentum in the y direction is equal to 0. The final momentum in the y direction is the y component of the momentum of the cue ball, which is mv sine theta. That, or we could place it over here. And then the component in the y direction for the 8-ball, which is going to be equal to m times 1.1 meters per second times the sine of 60 degrees. And since it is downwards, we're going to call that negative. So I've written then that this 0 is equal to mv sine theta minus m times 1.1 meters per second times the sine of 60 degrees. Again, the m's can be canceled out, and we can solve this for v sine theta and write that that is equal to 1.1 meters per second times the sine of 60 degrees. That turns out to be 0.953 meters per second. So now we have two equations and two unknowns. I want to take the second equation and divide it by the first one. The cosine of theta equals 1.65 meters per second. That will get rid of the v's, and I'll be left with sine theta over cosine theta, which is equal to the tangent of theta. So I can write then that the tangent of theta is equal to 0.953 over 1.65, which is 0.577. And if we find the inverse tangent then of 0.577, we find that the angle theta turns out to be 30 degrees. We can now find v. If we take either of these equations, let's take v sine theta is equal to 0.953 meters per second. Solve it for v. V then is 0.953 meters per second divided by the sine of 30 degrees. And if we carry out that calculation, we can show that this is equal to 1.91 meters per second. So that's the speed. The direction is 30 degrees. And our velocity then for the cue ball, our final velocity is a velocity with a speed of 1.91 meters per second at an angle of 30 degrees with respect to the x-axis. All right, that is a solution to problem number 5. Let's move on to the next problem.